Hey guys, today I'm going to go over how to use a multimeter and the basic functions. Now of course there's a lot of advanced functions that I won't cover today, but I'm going to go through most of the common usage of a multimeter. I'm really trying to grow this channel, so please give my videos a like, comment, and subscribe if you feel like it's helped you in any way. And I'll be coming out with more videos in the future. Now I'm going to be using the Fluke 77. It's pretty basic. Here's the off function. This is for AC current, like house outlets. This is DC, what you'll use for your cars. Millivolt, if you're trying to test for a parasitic drain or a small drain. Your ohms, if you want to test a motor for the resistance to see if anything's short, and it's a good test for continuity. Your diodes test, if you want to see if it's working properly. But also, if you want Audible, you could use this function while you're doing the ohms test. Your milliamp test, you can actually test how many milliamps your car is actually drawing, like your computer, your clock, your accessories. Over here is the amperage in AC, alternating current. So I'm going to try to go over all these so you can perform it. Most multimeter has the same thing. For this Fluke right here, it has most of the same function that I just described. But this clamp meter over here, you can use the flex, which you can add in a coil, so it's extra accessories that helps out. Now with this clamp meter right here, you could clamp it onto a wire and test their amperage without disconnecting. I'll show you that later on. Now this is the meter I use for home. It's a decent meter. It has more functions, but to be honest, I've almost never used them. These multimeters are very affordable. You can get them as low as $10, but it's worth spending a little extra for a decent one. The Flukes can be over several $100s. Now the Flukes are obviously the most expensive ones, and this one I think I picked up for around $50 to $75. But most of the meters that you have does the general purpose. So let's get on with the test. Now I'm going to start off with the basics. So right here I'm in this Ford truck. I'll be using direct current. So I'm going to switch it over here. Now it's okay if you see a little bit of reading. I usually clear this out. What you want to do on a car battery, when the car's not on, you want to read somewhere 12.6. That's the ideal voltage for a car battery. So you can hold it on the positive, red on the positive, black on the negative. So right now it's 12.47. And I want to say that's okay. And then if you can, you could stick your probe into the connector. If it'll stay, you can actually do a charging test. I'll teach you how to do that right now. So when I'm about to start, I'm going to expect the starter to draw amperage from the battery. So I'm going to see the voltage drop to near 10. And that's pretty common for most cars. So I am going to record. Here's a function that you want to record the minimum. So it's going to record the lowest voltage that this saw while starting the vehicle. Now 10.4 was the lowest, so that test passed. You don't want the voltage to drop below around 9.5 or so. That sort of shows a sign of the battery being weak or aged. Now that the car started, the alternator is charging the battery. Now for charging systems, you want to see around 14 volts of charging. If you see battery volts, that means the alternator is not charging or there's a bad connection somewhere. So I'm going to go back to the normal reading and I should see around 13 to 14 volts of charging. See, I have 14.06 volts, so that means the vehicle is charging the battery. Now to test if the alternator is reacting to the drop in voltage of the battery, I'm going to turn on the heater, the defroster, and everything that is going to take amperage, and I'm going to see this drop and increase. Now if you saw this drop and increase, that's because I'm putting a huge load on the charging system. I turn on the headlights, the high beam, the window defroster, and the heater on high. And the alternator detected that, and it raises amperage to maintain the charging system and keeps the battery charging. Because if you have an alternator that's not responsive, in a rainy day, say your windshield wipers running and everything, it will start draining the battery, and you wouldn't notice until you do it a couple of cycles and it fully drain your battery, and then you think you just need a jump start. So it's very important to know the root cause of your issue. Now I just turned off the car. At first it was charging at 14. So every time you turn off a car, your battery will have a static charge of above 13, and it's going to slowly drop. So you never want to take this as the reading of your battery. You want it to settle, or you can turn on your headlight a little bit to take away the surface charge. Now if you wait a while and you still see it dropping, you want to wait until it's settled, and that's your true reading. As of now, I wouldn't take this as my true reading. Let's move on to the next. Another test you could do with the voltage setting is testing out the coolant. I prefer doing this in a cold engine. Now what you're going to do is you're going to dunk these two terminals into the coolant, and you don't want it to go above 300 millivolts, which is 0.3 of a volt. Right here is 0.05. Now if you go to millivolts, it's 30 millivolts. So you don't want it to be 10 times as much, because now that could affect the electronics in the vehicle. Turn this into voltage. Now if you turn on the ignition, which is the second click, I'm expecting, and put the negative on the negative side of the battery, I'm going to expect to see power on both sides of the fuse. If you see power on one side and not the other, that fuse is bad. See, I see 12.5 on one side, and I should see the same on the other side. And you can go straight down the line with all the fuses. That's another quick way to test if there's power going through all the fuses, and if any of them are blown, so you don't have to pull out each one to see the condition of the filament. Now right here is a power strip for your house. It could be for some of your appliances or your computer. Now similar to a wall outlet, you can test this by going to the AC function over here, you can see this squiggly line. And with your probes, just stick it right here, you should see about 115 volts. Right here is 116.3. Therefore, you know that you have power in your outlet. Now this outlet right here is turned off in the breaker. So just to make sure that there's no power, you're gonna do the same. And as you can see, there's no power and it's safe to work on. I wanna check the top one too. Now for the red, you wanna go for the bigger spade. And for the ground, you could go for the smaller spade. You could reverse it, but it might show a negative over here. If you want to test the diodes for an alternator, this is a pretty typical alternator. You want to set your meter on the AC voltage, because what the alternator does is it creates alternating current, but the diodes inside is what turns it into DC current. So while the car is running and you have this on AC mode, alternating current, you want to set it on AC mode, the wavy line, while the car is running, and if you can reach it. If you can't reach it, you have to be very careful with this. With the black probe, you want to put this in the negative side of your battery, and while the car is running, you want to hold it next to the positive, and you don't want to see any reading here, because if you see any alternating current reading, then that means some of the diodes, one or more of the diodes inside the alternator is bad. Now I'm going to show you a live test. I'm going to leave this negative probe on the negative side of the battery. Now I can focus on the positive end. Now I set my meter on alternating current. And with this vehicle, it's pretty hard to reach because the positive is in the back of this boot. The positive is in the back of this boot, so I would have to remove the boot. While the car is running, I'm going to stick my terminal and touch right here. Now the probe is on the battery terminal of the alternator. This is acceptable. You don't want to see a lot more than that. So that verifies that the alternator diodes are all working. The engine is spinning the alternator, creating alternating current, and it's going through a bunch of diodes and into the battery as direct current, charging the battery. Thank you. Now I'm going to go over how to test resistance. Now this symbol right here is the ohm symbol, and that's the symbol for resistance. Whenever you turn over here, you're going to see OL, which is over limit, which means infinite resistance. So when you're in this mode, what the meter is sending a small amperage in the positive, and it's seeking a return on the negative. So once you touch, it's going to show you the resistance. So as you can see right here, this wire has a resistance of 0.1 or 0.2. If you have the option, you could zero this out. But if you can't zero out this meter, you can take this as a reference. So say you have 10.2, then you know your resistance is 10 ohms and not 10.2. Right here is a starting solenoid for a Ford truck. Now these two big terminals is the secondary, and the primary, where the copper winding is right here, and the ground. This is mounted on the chassis. So I would test here and here with my meter set at ohms. And since this is brand new, I have a reference to test on the one on the truck. So this one has a coil reading of 3.2, so it's 3 ohms. So if I go to the truck, I can test that one to see if it's close to the 3 ohms. If it's relatively low or high, then I know it needs some replacement. Or the connection is poor, or the wire is building up resistance. So that's the coil. For a relay, you could test the coil on it too. Here's a 24 volt relay. You could do the same thing. You could test the resistance of the relay. So here's the 2 terminals. 85 and 86 is the standard number to test the coil. Put it together, you have 323 ohms. And because this is a 24 volt relay. Same thing for this, is also a 24 volt. Not sure if you can see the diagram, but this is actually a diode relay. So I'll show you how to test this later on. This one has no diode, so you can test these two. Normally it's the 2 oddball terminals that are the coil. You can test this. You have 609 kilo ohms, quite a lot. Now on to the diode mode. Now when you come to the diode mode, this is actually a function that you could use 2 ways, because it also measures ohms over here. So if you touch it, one thing that's good about this is if it's quiet enough, you can actually hear an audible tone whenever this is touched. So this tells you that there's continuity crossing. If the resistance is too high, it won't cause an audible. It'll still do the ohm reading. See right here? You have 300 ohms, so it's doing the reading, but it doesn't have the audible, because the audible is supposed to show you that there is continuity. Now here's an example with my other meter. When you're in the resistance option, you can also have audible and diode testing. Now you hear the audible, at the same time you see 3.5 ohms, so it's doing 2 things at once. So this is when you don't have time to look at your meter all the time, but you want to make sure that there's continuity. So you put it in the audible position so you can hear the audible each time. Now right here is what they call a diode. Now if you see this gray strip, you know on the symbol side it's pointing where the strip is farthest to. So you know the power goes this way, but it doesn't go this way. It prevents surges. You want to use diodes if you want to protect sensitive electronics. So over here, in reverse, it won't work. But if you turn it around, you have 500 ohms. So this is actually a resistor diode. Here's a better example of the diode. So over here is a bunch of diodes. So what it really does is it connects this input to this output. And this is the diode that's keeping it. Right now I'm in the resistance mode and I set it onto the diode. You can see there's a diode symbol right here. I apologize for the glare. So I know that all the diodes are pointing upwards. So my positive, my input, has to be on the bottom, and my negative is the output on the top. As you can see, it's reading that it takes about half a volt for it to go through this diode. Now if I were to reverse this, it won't go through. That means the diode is working at blocking the current going past. So just keep in mind the positive has to go through the diode, not the other way around. So the positive has to go the direction of where the arrow is in the schematic. Again, half a volt, you reverse it, 0. So you could go down the line right here to test all the diodes. All the diodes. if you come here to here, you'll see that there's 537. But if you come over here, you won't see it because the diode is working. It's doing its job. It prevents any back surges back to the sensitive electronics. Now if you want to check the wiring if the continuity is good, say for instance, now I just pulled this wire out of my other meter and I want to check if there's any resistance or if there's good continuity in this wire. Because if you pull on this wire or tug on it, if you roll it over with something, you could break the internals without seeing it. So what I'm going to do is I'm going to use the diode test to see. I want to hear a really good audible. Now if I touch, now I have 0 ohms. That means this wire is good. If I see OL while I'm touching this wire could be bad. So if you're dealing with a really long wire, this is a good test. There are times when you have to test all the wires and you have no time to look into the meter. So it's good to just have this audible so you could just go down the line, and if you hear the audible, you can move on to the next one. Now a really great way to test for fuses is you can go to this diode mode right here, verify that the audible works, and in the back of the fuse you see these 2 terminals. You can just go down the line and check if each and every one of them is working. You want to see 0 ohms because if you see a high reading, it could be somewhere in the circuit that is closing. But if you go down the line right here, you can test if the fuse is good or not. Now if you don't hear the audible, that's the fuse that's blown. Another great way to use your resistance test over here in the ohms is you could test a lot of things that's around us. For instance, this is a typical headlight. This is a dual beam. If you look closely inside, there's 2 filaments. One filament is for the low beam and one filament is for the high beam. Now you can sometimes see if it's blown or not because you can see the filaments disconnected. But with the resistance test, there should be 3 terminals. One's the ground terminal, and the other 2 goes to the other 2 filaments. I'm going to just set it into the audible, which is the same, just to see that there's continuity. 0.6 ohms, 0.3 ohms. Now here is an 1156 light bulb. This is commonly used for turn signals and reverse lights. So the center part is where the positive goes to, and the body of this light bulb is the ground. Now if I touch this, I'm supposed to see a ohm reading. I have 18 ohms in this light bulb. Red to the center, ground to the body. I have resistance. I have about 30-ish ohms. Now you have to have a really good connection. Now I have about 10 ohms. That's the lowest reading I have. This is a dual filament. This is commonly used for brake lights and tail lights. So one of the filament is lower beam, that's for your tail light, and when you step on the brake, both of these light up, causing that brighter red light in the back. So the body is the ground, and these 2 terminals right here, One is for brakes and one is for tail light. So I'm going to test. This one has 4.1 ohms. The other one should have a double or half the amount. This is 2.5. So the 2.5 should be the brake light. Now if you can see, one has a coarser coil. So you're going to notice a resistant difference because one will be brighter than the other. Now with my hand on the body for grounding, one of the terminal is 4.2 ohms and the other one is 2.5, and because of that difference in ohms, one is brighter than the other. Now this right here is a pressure switch. Now whenever there's pressure, this ball bearing goes down and make contact between these two. Now instead of replacing parts, you can just hold both terminals and you press it with your bare hands to see if the switch is working. I'm letting go, open, pressing down, you see continuity going through. So this switch actually works. You can use the Audible, pressing down, letting go, pressing down. Same thing for these toggle switches. All it is two terminals. So if you were to hold on to here, so this is a normally open switch. When you flick it on, I'm supposed to hear Audible. Which means it's making continuity. So it's always nice to know how to test the parts before you replace it. It could save you a lot of money. And for this starter solenoid, I know that there's a coil winding on the primary and the secondary should be open at all times until this is energized. When the primary is energized, then the secondary closes. So right now I'm expecting this to be closed, so right now I'm expecting this to be open and no continuity going through, as expected. But I'm expecting resistance on the primary circuit. There's about 3 ohms on this coil. Right here's the starter solenoid. For the resistance mode, you can actually test how good your body ground is. So make sure whatever you're testing, the bolt is clean with no paint on top. As you can see, I'm touching a bolt that has paint on it. So it's going to have a really high reading, if any reading at all. Now if you were to touch the engine block, I'm touching the aluminum part of the engine block, you're going to have a reading. So you have 0.3 ohms, which is pretty good for a body ground. So now you know that the engine is grounded to the battery. Now you can do these tests on ground straps. Usually you see it in the fender. Now if you have a relatively high resistance on the ground strap, it's either really old and brittle or it's a poor connection, so you might want to check there. It could restore some performance in your vehicle. Now the next test I'm going to show you is the amperage test, which is right here. Now if you turn it over here, you'll see that it says lead for split second. What you want to do, because the leads have to be right here, either in milliamps or amperage, 10 amps. So you have to switch this over. You have to switch the power, the positive, into the 10 amp. Now you're ready to read the amperage. Now what you're really doing, you're pretty much putting this in between the circuit, and then this is going to read the amperage that's going in and out. Now you don't want to do anything too crazy, like starting a car with it, but anything for like a light bulb or something, or testing for a drain, this is perfect. So the leads you want to start off at the 10 amp first. Now you're ready. So here's a little trick that I do. I loosen the positive cable, but I don't remove it. The car is off right now. So what you're testing for right now is to see how small of a drain your car is taking. So you want a good connection on the terminal. At the same time, you want to put the positive right in the center. Now what you're going to do is you're going to raise this and hover it. You see this? Now you know right now this is separated. Now you tapped in the meter in between this circuit. Now I'm going to plug it back in. Now right now I'm going to purposely turn on the light and we're going to do an amperage test again. I've opened up the door, so I'm going to expect some amperage, maybe like a 1 amp draw on this. Now you can use this clamp on meter right here to test for amperage also. What you do, you turn it into the amperage and you want to clamp it in the direction. And it says press the yellow to clear 0. Now we're at 0. And when you clamp around the circuit, it'll show a reading. 0.6 amps. So you have about half an amp going through that light bulb. This tool is a must-have if you're learning electrical. And the more you use it, the more familiar you'll get. Thank you so much for watching till the end. If you haven't yet, please like, comment, and subscribe. Take care.